If cos of 60 is equal to cos 45 times cos theta, theta is between 0 and 90 inclusive, theta is equal to. All right, got a little bit of trigonometry for you, and you're allowed to use a calculator on the Canadian exams, which is great. So this, some of you probably have this memorized. You don't even need a calculator, but if you do, there's nothing wrong with using one. That's a half, and cos of 45 is root 2 over 2 times cos of theta. And then just isolate for cos theta, and you will get, what will you get? 1 over root 2? Yeah. And then that is, if you rationalize the denominator, root 2 over 2. And you either know this by memory, or you can just do it in your calculator, inverse function. And when you do, you get theta is equal to 45 degrees. So number 12, the answer is D. In the country of no hills, each pair of cities is connected by a straight and flat road. The chart to the right shows the distances along the straight roads between some pairs of cities. The distance along the straight road between city P and city R is closest to. Well, P and Q are 25, whatever the units are, 25 something, meters, kilometers, so let's say that's P and that's Q. And I was staring at this, and immediately these numbers made me think of, and I'm sure even you figured it out, a Pythagorean relationship, right? Because 7, 24, and 25 is definitely a Pythagorean relationship. So that's why I immediately figured out that this has got to be a triangle, a right triangle in particular. Okay, so let's move forward. P and S is 24. So I believe that is probably going to be one of the side lengths. And then we've got Q and S is 7. Okay, so that means from here to here is going to be 7. Now this isn't drawn to scale, but that's okay. Let's label this now. PQ was 25, PS is 24, and SQ is 7, right? The distance from P to Q is 25, the distance from P to S is 24, and the distance from S to Q, or Q to S, either way, is 7. And this does indeed work out to be a Pythagorean relationship, because 24 squared plus 7 squared is equal to 25 squared. Now there's one other city that I have to put in, that's R. Now R to S is 18. So that means I've got to extend this line, and it's got to go 18 like this. So this is R, and this is 18. And that means RQ, from R to Q, is 18 plus 7, which is 25. Let's see, R to Q is indeed 25. So great, it matches. So now my task is to figure out the distance from P to R. So that should be pretty straightforward using Pythagoras. PR squared is equal to 24 squared plus 18 squared. So that's going to be 576 plus 324, and that is 900. So therefore PR is the square root of 900, which is 30. So number 22, the answer is A. In the diagram, the 6 small squares have side length 2. Lines are drawn from O to P and O to Q. The measure of angle POQ in degrees accurate to 1 decimal place is. All right. Well, first and foremost, we have to understand that this is a square, this whole thing. And when you draw a diagonal like that, you cut the angle as follows. This becomes 45 degrees, right? Because the whole thing is 90. So that first and foremost, we just figured out that's 45. It's pretty straightforward. Now we want to figure out this angle right here. That is representing POQ, right? So I guess the next angle we need to figure out is this guy right here. That one, I'm going to use trigonometry, and this is grade 11, so I think trigonometry by grade 11 is acceptable as a method. So tan is what I'm going to use. I'll call that x, or I'll call it theta. I think theta is a better symbol to use. So the tan of theta, well, they tell you that those are 2, the distances. All the squares have side length 2. So the tan of theta will be 2 over 6. And you're allowed to use calculators on the Canadian exams, and if you do, and you figure out the inverse tan of a third, you get theta is equal to 18.4 approximately. So this right there, that angle, which is angle POQ, will be 90, because this whole thing is 90, right? Minus 45 minus theta, which is 18.4. And if you do the math, you get 26.56 approximately. So that is going to be C. A 4x4 square piece of paper is cut into 2 identical pieces along its diagonal. The resulting triangular pieces of paper are each cut into 2 identical pieces. Each of the 4 resulting pieces is cut into 2 identical pieces. Each of the 8 new resulting pieces is finally cut into 2 identical pieces. The length of the longest edge of one of these final 16 pieces of paper is... Well, the first 3 they've already given you, right? So I don't need to draw them out. Let's just talk about them. The first one is just a 4x4x4 square, so those sides are all labeled. This one, to figure out all sides, we just use simple Pythagoras. These 2 are obviously labeled, so the diagonal, we use simple Pythagoras, and that's 4 squared plus 4 squared is equal to, say, call it d squared. And if you do that, we'll just do it here on the side. 4 squared plus 4 squared is d squared, and therefore that's 2 times 4 squared is d squared, and therefore d will be 4 root 2, which is going to be this diagonal, 4 root 2, that length right there. And then what happens is then you cut it into shape like that. But what's interesting is that 4 still remains. I'll draw it a little bit bigger here. It becomes something like this. Now, this is 4, and I just took this triangle and just made it a little bit bigger. This is a right angle, because when you cut it like that, those diagonals meet at right angles because it's a square. So that means that this and this are the same. How do you know that? Because if that's 90, this is 45, and this is 45, right? And this is going to be the same as that. You basically have chopped the square into 4, and then each of those diagonals is chopped in half. So that means we can easily call this and this x, and we can use Pythagoras once again to figure out the value of x. X squared plus x squared is 4 squared, 2x squared is 16, and therefore x squared is 8, so therefore x is 2 root 2. Okay, so far so good. So it's this side right there that's 2 root 2. So that side right there, 2 root 2. Okay, that's x. Now we've got 2 more scenarios. That is, we got to take one of these guys and chop it in half. Okay, we can do that. It's actually this one right here that we're chopping in half. So we're going to chop it in half, so it's going to look something like this. Right? I just basically cut it down the middle. Now let's talk about the dimensions there. Well, this whole thing was 4, so that means this has got to be 2. This part is x, and that doesn't change, interestingly, so that's 2 root 2. Right? And then this is 90, and this side, even if I don't know what it is, I can easily figure it out using Pythagoras. 2 squared plus y squared is 2 root 2 squared. So that's 4 plus y squared is 4 times 2, which is 8. Therefore, y squared is equal to 4, and y is equal to 2. Okay, y is 2. And now we have one final cut to make, which is cut this in half. So I'll draw that again. Over here, we got to take that and cut it in half like this. That's the last one. Well, this side doesn't change. That's just 2. This side is going to be this side divided by 2. So that was 2 root 2, so that means this is just going to be root 2. And then again, this is a right angle. So that means I can use Pythagoras once again to figure that out. Well, z squared plus root 2 squared is going to be 2 squared. So that means z squared plus 2 is equal to 4, and therefore z squared is equal to 2. That means z is root 2. And what they're asking for is the longest edge of one of the final 16 pieces. And this is the one of the final 16 pieces. The longest edge, obviously, is just 2. Because the other sides are root 2, and root 2 is approximately 1.4. So 2 is the answer. So number 18, that would be choice B. In the diagram, R is on QS. QR is equal to 8, PR is equal to 12, PRQ is 120, and RPS is 90. What is the area of QPS? QPS. Okay, so the big triangle is the area they want us to figure out. All right. Well, where do we want to start here? I guess this is all similar triangles in the sense that they're all 30, 60, 90, right? Because if this is 120, then this is 60, and then this is 90, and that means this is 30. So this is a 30, 60, 90 triangle, and the ratio of the sides are 1, 2, and root 3. So immediately using the ratio, we can figure out RS. RS over RP is the same as 2 over 1. So solving, we get RS is equal to 2RP, and RP is 12, so RS is equal to 24. So there we go, put 24 right there. And then at this point, I am going to have to draw a perpendicular from P down to the bottom like that, like this. So that is a right angle. And that will allow me to figure out my height, because I need a height to figure out the area of the triangle. And I'll call that height H. Let's call it H right there. Well, this is again a 30, 60, 90 triangle. This is 60, and this is 90, because that was a perpendicular. So therefore, this little guy is 30 degrees. So that means that H over 12 is the equivalent of, let's see here, that'll be 1 root 3 in terms of the ratios of the sides, and 2. So H over 12 is the same as root 3 over 2. So that means H is equal to 6 root 3. Correct? All right, great. We're done. So area of that big guy, QPS, is 1/2 base times height. The base is this whole distance, which is 8 plus 24, which is 32. And the height is H, which is 6 root 3. So this looks like 3 times 32, so 96 root 3. And therefore, number 19, the answer is E.